In this tutorial, we'll build a Simon Says memory game using an Arduino. This circuit uses LEDs, push buttons, a buzzer, and a potentiometer. You'll learn step by step how to wire each component inside Tinkercad circuits and prepare for programming the game logic. First, open Tinkercad in your browser and log into your account. On the Tinkercad dashboard, click the blue Create icon at the top right, then choose Circuits. This opens up the new Tinkercad workspace where you'll build your Simon Says memory game circuit. Click the project name bar at the top left and rename it to Simon Says. On the right-hand side of your workspace, you'll see the Components panel. Make sure to choose All from the Components bar rather than Basics so you can access to all the components. In the search bar there, type Arduino UNO R3. When it shows up in the results, click and drag it into the workspace. Now, we need to rotate it to match our preferred layout. In the toolbar above, you'll see the rotate buttons. Click the rotate button 3 times, or press Ctrl plus or 3 times. This will make wiring easier and keep the circuit neat. For better visibility, you can zoom in and out of the workspace using your mouse scroll wheel. Next, in the same search bar, type Breadboard Small. Drag the Breadboard Small into your workspace, rotate it 3 times as well. Along the sides of the breadboard, you'll notice 2 long rails. The red rail marked with a plus sign is your power rail, and the black one with a minus sign is your ground rail. These are used to distribute power across your circuit. We'll place it just beside the Arduino so that connections are short and tidy. Now it's time to power the breadboard. Click on the Arduino's GND pin on the left side of the board. When you click a pin, Tinkercad automatically brings up the wire tool. Drag a wire from the GND pin over to the ground rail on your breadboard. Once the wire is in place, click the small colored square on the wire to open the color palette, then select black to make it easier to identify. While any color works electrically, it's best practice to use red for power, black for ground, and different colors for other connections to keep circuits organized and easy to understand. You can either draw the wire first and then change its color, or select the color before drawing. Both methods work fine. You can adjust the shape of a jumper wire by clicking and dragging its corners. This helps you keep your circuit layout neat and organized. Now, we'll connect the Arduino's digital pins to the breadboard. Connect digital pin D10 on the Arduino to breadboard hole F1 with an orange wire. Connect pin D9 to J7 and D8 to J12 with a blue wire. Connect pin D7 to J13 and D6 to J18 with a green wire. Connect pin D5 to J19 and D4 to J24 with a yellow wire. And connect pin D3 to J25 and D2 to J30 with a pink wire. Let's make sure our components get power. Connect D2 to the ground rail on the breadboard using black wire. Bridge E1 to F3 to complete the ground connection near the buzzer. Finally, connect these button points J10, J16, J22, J28 to the ground rail so that each push button has one leg tied to ground. Let's add the buzzer to provide audio feedback in the game. Go to the Components panel, search buzzer, you'll see an option called piezo appear. Click and drag the piezo buzzer into your workspace to add it to your circuit. A piezo buzzer is a small electronic component that produces sound when a voltage is applied, commonly used for alerts and tones in electronic projects. Now, rotate the buzzer to match the layout. Connect its positive terminal to H1 and its negative terminal to H3 using jumper wires. Let's add the LEDs, which will light up in sequence as the player must repeat. First, search for LED in the components list and drag one into the workspace. Click on the LED and change its color to blue. Rotate it so it matches the layout. Now, place the anode into H7 and the cathode into H8. Next, copy and paste this LED to create another one. Change its color to green and place its anode into H13 and cathode into H14. Copy and paste the LED again. Change its color to yellow and place the anode into H19 and cathode into H20. Copy and paste one last time. Change color to red. Place anode into H25, cathode into H26. Let's add the potentiometer to adjust the game speed. Search for potentiometer in the components list and drag it into the workspace. Then, in the right-hand inspector, set its value to 10 k-ohms. Rotate the component so that its three terminals align perfectly with the breadboard holes at B1, B2, and B3. Let's add the push buttons, which act as the game's control. Search for push button in the components list, and drag one into the workspace. Rotate it 3 times so it aligns with the breadboard layout. Then, place the first push button across the breadboard gap so its legs sit in E10, E12, F10, and F12. Now, copy and paste it to add the second push button. Position it so the legs line up with E16, E18, F16, and F18. Now, copy and paste again for the third push button. Place its legs into E22, E24, F22, and F24. Repeat the same process one last time. Copy and paste again, and this time place the fourth push button into E28, E30, F28, and F30. Let's add resistors to protect the LEDs from burning out. Now, search for resistor and drag it in. It will default to 1 k-ohms. Click on the resistor, then change the resistance value to 330 ohms. Rotate it 3 times so it matches the layout. When adding resistors, connect each resistor from the cathode row of the LED to the ground rail. Then, connect one terminal between J8 and the ground rail on the breadboard. Next, copy and paste the resistor, and place the new one between J14 and the ground rail. Copy and paste again, and place the third resistor between J20 and the ground rail. Finally, copy and paste once more, and place the last resistor between J26 and the ground rail. That's it, our Simon Says hardware circuit is fully wired with, for LEDs for the sequence, for push buttons for player input, a buzzer for sound feedback, and a potentiometer to adjust game speed. Now, let's program the Arduino. At the top right corner of your screen, click the code button. By default, it opens in block code mode. Change it to text mode by clicking the drop-down in the top left of the code window. delete the starter code inside. Then, start typing the code for our Simon Says game circuit. Set up buttons, LEDs, tones, and buzzer pins. Reserve sequence and round tracking variables. In setup, configure buttons as input_pull-up and LEDs as outputs. Set buzzer pin as output. If the game hasn't started, play the start sequence. Show the current pattern by flashing LEDs with sounds. Wait for player input, checking buttons, or timeout for each step. If the pressed button is correct, continue. If not, play the lose sequence. If time runs out, play the lose sequence. After a round, go to the next round if not finished. If all rounds are complete, play the win sequence and reset. All flashing, button checks, wins, and loses are handled by reusable functions. Let's start the simulation. Now, go to the top of the screen and click Start Simulation. If there are errors in the code, it will show up on the screen after clicking Start Simulation. Just check the message and fix the issue and start simulation again. You'll notice the circuit will flash all of the LEDs and play a melody. And you can even adjust the volume by rotating the potentiometer knob. After a few seconds, it will flash the first light in the pattern. If you repeat the pattern correctly by pressing the corresponding colored button, then the game will move to the next round and add another color to the pattern sequence. If you make a mistake, the game over melody will play and the game ends immediately. Press the reset button to restart the game. As you keep playing, pay close attention to the LED sequence. If you press the wrong button, it's game over again. Congratulations, you've just built your own Simon Says game circuit inside Tinkercad, combining Arduino and LEDs.